I'm Aditya. I want to introduce a fast algorithm for global scheduling in SSA form. This is a Midland optimization. It is more like a generalization of GVN hoist and GVN sync, but we have more like improved cost model and some very interesting stuff. We're using modern data structure. We augment the SSA to help find the opportunities much faster. And it also uses the DJ graph, which helps fast liveness analysis in SSA form. So a little bit of insight into how the SSA has been augmented. At each branch or branch out or merge point, we insert specific nodes. On the branch out, we insert a node which we call as alpha nodes, which keeps track of the live out of variables. And if the node has like two branch out, then the alpha node will have two entries. And the interesting part is these entries track the identical values. Like we compute the GVN of those values, and those args are filled with identical values. So essentially, if the nodes have complete full entries, that means that that variable is anticipable at all the points, all the successors. And the opposite holds for, similar things hold for the branch in, where we insert phi nodes in general. Here we call them as beta nodes. So if the incoming values, like identical incoming values from all the predecessors, then that node will be filled. And this helps figure out which instructions can be scheduled without the concern for safety and especially for scalar values. For this actually helps schedule instruction to different basic blocks. The cost model is based on liveness of virtual registers. The goal is to reduce register pressure. So we only schedule, like move the instructions to a different basic block in case the register pressure either reduces or does not change. So after this global scheduling pass, the overall live range will be less. And this is reflected in the register, the spill cost, the total number of spills when we run the benchmark. Global scheduling has like essentially two parts. One is hoisting and followed by syncing. We do the hoisting first because that uncovers like more opportunities, and then syncing, because syncing does not have so many opportunities when we are running the benchmarks. Here are some interesting results. We saw improvements in SPEC 2006 benchmark. The most impactful one was MILC, where we saw 15%, and LLVM has around 7%. Others 2-3%, which are also quite meaningful. The patch is on LLVM Fabricator, and the references are like GVN hoist and GVN sync has some ideas there as well. This patch is up for review. This is a slightly older work. You can see from the diff number, it's 32,000. It's been a few years when this patch was submitted. So I would request people to go and review the patch. Thank you.